Hi guys, today we are going to talk about polynomials. Then to talk about polynomials, first we have to talk about a monomial. And a monomial is an expression of the type ax to the n, where a is a real number constant and n is a non-negative integer number. Okay, then one example, negative 8 x to the 7th, but another example can be 4x, or can be just 8, or can be 20 x to the 8th power. That's an example for monomials. Now, a polynomial is a monomial, or a combination of sums and or differences of monomials. Okay, then let's check this example. 2 minus x cubed plus 5x minus 8x to the 7th power. That is an example of polynomials. Okay, as you can see, polynomial is formed by one or many monomials. If we are talking about polynomials, it's also important to talk about evaluating polynomials. Okay, then when we replace the variable of a polynomial with a given number, the polynomial then represents a number called a value of the polynomial. Finding that number is called evaluating the polynomial. Then, in other words, evaluate the polynomial is replace a polynomial, all of the variables of the polynomial, by a given value. In this case, evaluate the polynomial when x is equals negative 4. The polynomial is 2 minus x cubed. Then what we have to do, replace x by negative 4 because it's the given value. Okay, then that's the first step. Everything is exactly the same, but x is replaced already. Okay, now of course we have to solve the power. Then negative 4 to the cubed is going to be negative 64. 2 of course is exactly the same, and minus is exactly the same. Now we have double minus, double negative signs. Okay, then everybody knows that it's going to be plus 2 plus 64, and 2 plus 64 of course is 66. Now let's check the example B, that is an application. During the first 3 seconds of a jump, the distance s in feet that a skydiver falls in t seconds can be approximated by the polynomial equation s equals s equals 11.12 t squared. A group of friends fell headfirst in formation from the height of 18,000 feet. How far had they fallen 10 seconds after having jumped from the plane? In this case, of course, remember that we are talking about and evaluate the polynomial, but in this case it's in a context, in a word problem. Then what we have to do is find s value replacing t value, because the s means distance in feet and t means time in seconds in this case. Then we know that the time is t seconds. Okay, then we have to find what is s value. Then what do we have to do? S is equals 11.12 times t, but in this case t is 10. T square, of course. Okay, 10 is t. Then 10 square is 100. Then 11.12 times 100. 11.12 times 100, of course, is 1,112 feet, of course. That is the answer for this word problem. Then how far is the question? Then the answer is going to be the group of friends are 1,112 feet far from the plane 10 seconds after to the jump. Okay. Another thing that is important is identify terms and classify polynomials. How can we identify terms? When a polynomial is written using only addition, the monomials being added are called terms. Okay? Then, in other words, very simple. When we identify each part, each monomial of the polynomial, that is a term. Then 2 is one term. -3 cubed is another term, second term, for example. 5x, another term. And -8x to the 7th power is another term. Okay? When we have to classify polynomials, we have to remember the name of the polynomials. Okay? Then polynomials with just one term are called monomials. Polynomials with just two terms are called binomials. Those with just three terms are called trinomials. And those with more than three terms are generally not specified with a name. Then doesn't exist a name for four terms, for monomials or more. Okay, then we say that it's just a monomial. Then in this case, this polynomial that we are talking about is a polynomial. Doesn't exist another specific name. Just exists a specific name for one term or one monomial, 2, 3 monomials. Next, the coefficients and degrees of the polynomials. Then first, let's talk about the coefficient. Coefficient is the big number that is close to the variable. Okay, remember that the small is the power. Then we are talking about the other one. Okay, then for example, let's analyze this term, -8x to the 7th power. In that case, -8 is the coefficient. In the next one, 5x, 5 is the coefficient. Next one, -8 x cubed. In that case, -1 is the coefficient, because remember there is a 1 there. That is maybe not possible to see, but it's a 1 there. And in this case, 2 is the coefficient. Okay? Now, let's talk about the degrees. The degree of a term, be careful, the degree of a term. Okay, then we're talking about just, for example, -8x to the 7th. That's a term. Then the degree of a term is the exponent of the variable. Then in that case, -8x to the 7th power. 7 is the degree of the term, of this term. But if we are talking about now about the polynomial, the whole polynomial, then the degree of a polynomial is the largest of the degrees of the terms. Then in this case, what is the largest exponent? The largest exponent in this case is 7. Then the whole polynomial is, the degree of the whole polynomial is 7 degree. Okay? Then let's continue. Collecting like terms. Collecting like terms. When terms have the same variable and the same exponent, we say that they are like terms. We can collect like terms just when we identify first the like terms. Okay? We can often simplify polynomials by collecting like terms. Collecting like terms means add or subtract the like terms. Then in this case, for example, we have two pairs of like terms, 2x and 5x. They are like terms. -x to the 5th power and -8 to the -8 x to the 5th power. They are the second pair of like terms. Then we have to add them. 2x plus 8 plus 5x is 7x, and -x to the 5th and -8x to the 5th is, of course, -9x to the 5th. Okay, now let's talk about the order. Order. A polynomial is written in descending order when the term with the largest degree is written first. Then the term with the next largest degree is written next, and so on, in order from left to right. Then let's organize this polynomial in a descending order. Then the term with the greatest exponent is first, the next one and the next one, and the next one, from left to the right. Okay, just to clarify, the opposite of descending order is called ascending order. An ascending order, then we start, the first term is going to be this with the smallest exponent. Okay, from left to right. Then at right is going to be the greatest or the largest exponent if we are talking about the ascending order. Now let's talk about the missing terms. Missing terms. If a coefficient is 0, we generally don't write the term. We say that they have a missing terms. Then look at this. The first thing is, let's use this example and organize in descending, perfect descending order. When I say perfect, I mean 7, 6, 5, 4, 3, 2, 1, and 0. What is the missing terms? The missing terms are the terms with 0, when 0 as a coefficient, okay, like this one over here. Then what is the missing terms? This one are the missing terms. Guys, that's all. Thank you.